Okay, I left off the last video telling you guys that we were going to work on this problem. And so we want to know the length of AC. L equals question mark. Don't know the length of that. We know the spring constant of this. LAB 0 unstretched is 0.4 meters. Okay. This is 30 degrees. And here's the free body diagram over here. We have the three forces, which we'll find out in just a second here. And the actual value, let's go to my calculator. There it is. 78.48 is what I would store in my memory. Memory recall. Keep that 78.48 in memory. Okay, next slide. We have two equations, sum of forces in the x direction. Let's go back. So TAB minus TAC cosine 30 is going to equal 0. TAB minus TAC cosine 30 has to equal 0. The y direction forces, TAC sine of 30 minus 78.48 is going to equal 0. And when you crunch the numbers, get TAB and two equations and two unknowns. You can solve for TAC, and then once you've got that, you can substitute it in here and get TAB. So that this is an easy calculator problem. Now, once we know TAB, now this free body diagram is the force acting on the ring. The force acting on the spring is in the opposite direction. Force acting on the ring this way, force acting on the spring this way. Okay. Let's see. TAB 135.9 down. 300 newtons per meter. That's the spring constant times whatever that length is. We get 453 meters. Go back. 0.453 here. Two minus this gives us the total length. Well, from then on, it's trigonometry. 2 minus 0.453. Units in meters. And then that's that length. Then once you know the one side, the total length cosine 30 is going to be given by that value, by this value. Okay, and we're going to have it. Oh yeah, that's the stretch. Okay, I'm sorry, I forgot something. Unstretched, 853. Unstretched is here. Stretched is here. So let's go back. I said 453. Erase the 4. These are the kinds of common mistakes, the things that we forget that, you've got the concept, you've got the right idea. This is the kind of thing I won't hold against you on the quizzes and exams. In fact, I might, on some of the exams, I might ask you to strictly work in variables, not in numbers at all. Okay. 853. Then like I said, LAC cosine 30 plus 0.853 will have to equal 2, and then solve for LAC. That's the end. Now, 3 dimensions. Let's dive into 3 dimensions. Same ideas. Sum of all the forces has to equal 0. Sum of all the forces in the z direction has to equal 0. Y direction has to equal 0. X direction has to equal 0. Same procedure that we did earlier. So let's take a look at the next problem. 10 kilogram lamp, which is W equals 98.1 newtons. And that's an exact number. 3 equal chords. What we want to know is the smallest vertical distance where the force is 50 newtons. Okay, so we have the 3 chords. We don't know this angle right here, but they're all the same for all 3 of them. So we have t cosine 30 is going to be the z-axis forces, and the only force acting down is in the z-axis. The other 3 are equal and symmetric, so they are going to they're going to sum to 0. The x and y plane forces are going to sum to 0. And once we've got this, we want to say, okay, T equals 50 newtons. And basically it's to find gamma, and then we can find S. There's S right there. Okay. So applying the equilibrium equations, this is the force acting down, the weight. This is 3 times the 50 newtons, the force in each cable, times the cosine of gamma, and we can solve for the cosine of gamma then. Okay. The tangent of gamma is going to equal that 600 millimeters divided by the total length. So that gives us our answer. Not too tough. And we're going to wind up the video on this particular problem, but I'm going to go ahead and end this video here and pick up this problem in the final video for Chapter 3. The other examples in the book, by the way, do yourselves. The examples I'm doing are representative of the chapter. These, the rest of the examples, go through on your own. Practice on your own. Understand them on your own. And with that, I'm going to end part 2. One last part for this video.